Hey everyone, welcome to Zabbix Spotlight. Today I'm here with Mark Vilensky from Weizmann Institute of Science. Mark, introduce us a bit. Tell us a bit about yourself, your experience with Zabbix.
My name is Mark Vilensky, and actually I'm a physicist or chemist. I did my PhD in the Weizmann Institute, and I was offered to stay in the institute and to manage the high-performance computing infrastructure. So we created a chemistry faculty HPC. In 2009, I got the funding and the space in the data center, and we built our system, which is continuously growing and develops. And last year, we faced problems with the existing monitoring system and started looking for alternatives, and we decided to switch to Zabbix. So I currently use Zabbix for 10 months, since December last year, and I have to admit that we are happy.
Good to hear that. It's very plain and simple. Admit that I'm happy with Zabbix. Yeah, glad to hear that. You mentioned high performance computing, HPC, right? Can you tell us a bit about what it is and how it's different from regular IT?
HPC is a very interesting world. First of all, you have almost all the same challenges that you have with the regular IT, like you have networking, you have switches, you have servers, you have hosts, you have software, you have users that sometimes do something wrong by mistake, usually and hopefully. But the problem is scaling and automation. Like in IT, you can have like 2, 3, 4 servers of the same type. I have hundreds of servers of the same type. My system is not very big, like it's not one of top 500 systems, even though it's one of the biggest in Israel, but I have 600 nodes. Sometimes I have 100 or 150 nodes of the same type, and the crucial point is scaling and automation. So if I bring in 2 words difference between HPC and normal IT, it's scaling and automation. Scaling, because you have to remember every time you do something, even though it may seem that it works fast, like only 2 or 3 seconds, but in the background you have to remember that this number can be multiplied by 100 or even by 1000. So 2 seconds by 100 already takes 3 minutes. 3 seconds by 100 already 5 minutes. So if you do a check or a test or something that is very fast, only 3 seconds, on your system, it can run up to half an hour easily. Mm-hmm. And automation, when I buy new equipment, and like normal purchase is about 100, 150 servers, I want to introduce them to my monitoring system. I don't want to define them by one. So auto-discovery is a crucial point.
Mm-hmm. And okay, so you've defined how HPC is different from regular IT, and now let's focus on why did you go with Zabbix? Why did you decide going with Zabbix as opposed to any other solution out there?
Okay. After some time I'm using Zabbix, I'm very happy with it, but I sadly would say that there is not so many choices. We had Nagios Ganglia monitoring system, but these projects have died. So they are not supported on modern operating systems, starting from Red Hat 8. There is an option to use Prometheus for real-world system, not for Kubernetes, but you really lose all the advantages of Prometheus when you run it on hardware servers. And not that I know good commercial alternatives. There is Insignia. I even don't know. There is some G I heard, but like you pay money and then you work the same amount of time that you work for configuring Zabbix. So I don't really get the idea. Like I use commercial products in our system, but my approach is when you get a commercial product, then you pay for a product, it has to work out of the box. If you buy a product and then you have to buy professional services, or you have to invest 100 hours to configure and to bring to the situation where it works smoothly, then I don't see a point to pay for it.
So the fact that Zabbix was free played a role. Did the fact that it's open source also, did it play a role?
Yes, because you can add some functionality to the Zabbix. We do some external tests, so if you can add your own checks, it's a good point. So yes, there is advantage for using open source.
Okay, and maybe you can tell us a bit more about what you're monitoring. So okay, we've defined HPC, we know you're using Zabbix. Give us some examples of metrics and how they're being monitored. How are you using Zabbix?
First of all, we use Zabbix for monitoring what I call operating system, and we use it for monitoring Ethernet switches. So Ethernet switches we monitor via SNMP. We monitor the crucial parameters. I have redundant power supplies on switches, so if one of the power supplies goes down, I want to know. We have redundant fans. If fans are broken, I want to know in order to replace before I lose the redundancy on my system. We monitor if there is strange changes in the speed of the ports. Like if the port operates on 1 gig Ethernet and for some reason started operating on 100 megabit, we want to know. So this is one. And hosts, we monitor the operating system parameters. We monitor load, we monitor memory utilization, we monitor disk space. We change the priority of the alerts because, for example, on the compute node, if it's overloaded, it's okay because HPC is the point to use CPU at 100% or even more. So it's absolutely not critical alert when you have 100% CPU utilization. From the other point of view, if I have on GPFS server 100% CPU utilization, I should be aware of it. So this flexibility in Zabbix that you can define the host group and define metrics and define templates for different hosts and to change the level of the alert. So on one host, the overload of CPU will be critical and the other host it will be medium. It's a very interesting point. And these are the metrics. So we measure CPU, we measure partition, we measure memory, network traffic. Last time we had some problem with our storage, so we started monitoring the space on our GPFS. GPFS is an IBM product. It's a general parallel file system that is used for the HPC clusters. So we started monitoring space last month.
Okay, we've also talked about, at least in the context of HPC, about automation and scalability. So I assume that also applies to Zabbix, that in that case, automation for Zabbix is also important. What kind of automation features you're using in Zabbix, for example, network discovery or
auto discovery?
Oh, okay. Are you using
auto discovery and templates? We prepare. For example, we have 100 nodes with CPU. I don't know, 6340. Xeon Gold 6340 and 256 gigabyte, and they have certain SSD capacity. So we create a template for these compute nodes and auto discover them, and we monitor parameters relevant to this host.
So you're probably using a combination of both. Either auto registration, which is agent only, or network discovery, and also low-level discovery features, right? Where Zabbix can automatically discover your CPUs, your hard drives, whatever else you have. Yeah. Okay, and what about scalability? How do you ensure that your Zabbix is scalable?
Zabbix has agents. For example, Nagios doesn't have agents. Nagios checks everything centrally. So in order to make Nagios scalable, it always combined with Ganglia. Ganglia has agent, similar to Zabbix, and agent sends information like partitioning, like disk space utilization. In Zabbix, you have it from the box. Like with agent, you have checks. You can define which checks are passive, which checks are active. Like if server pulls the data, or agent, or push, or ask for the data.
Yeah.
So it's in terms of scalability, it's excellent. Like we monitor with one server without any proxy. We monitor 600 hosts, more than 600 hosts, plus switches. And our VM is fine, like we don't have spikes on CPU or memory utilization or disk I/O.
What I think our community is always interested in when it comes to scalability is what kind of database backend do you use?
This, we had a good starting point because we started from scratch with Zabbix. And I found this great channel by Dmitry Lambert. And he has these videos about, he has many videos about how to do things in Zabbix, but he has several videos about planning. So how do you choose the correct database? What is a timescale DB? So because we have this freedom of choosing our starting point, we started with Postgres with timescale DB. So we from the beginning do not have database problems. Like all those problems that Dmitry speaks on his videos about housekeeping the data, we do not have them.
Because of automated partitioning.
Because of automated partition, because a good start. Like we started smartly.
That's good. That's the way to go. Did you have any experience with Postgres or timescale previously, or did you just sort of figure things out as you went along?
We use Postgres quite a lot, but not directly. Like I have PBS Professional for the job scheduling on the cluster. There is Postgres database underneath. I used HPSIM for hardware monitoring of HPE hardware. There is Postgres underneath. So I know basics of Postgres database operation, but not that me or anyone of my team are database experts.
So you're not a DBA, and you were still able to tune the database backend sufficiently so it behaves nicely with 600 and probably even more hosts over time.
Look, I don't want to be not modest, but I did my PhD in physics, and other guy in my team also has PhD in physics. So we didn't have experience with Postgres, but we read a couple of resources about Postgres installation and some optimizations, and we did it, and it works. Maybe we did it not the best way, but our system is stable and works smoothly.
Okay, so we now know what your Zabbix environment is like. Let's talk a bit about the future. First off, do you have any personal plans for your own environment, something that you want to implement in the future, but you haven't done yet, and anything that you're looking forward to doing?
First of all, similar to many organizations in the world, our institute runs out of electricity and out of cooling capacity. So even though we have a physical space in our data center, but we don't have enough energy. So we most probably, if we want to increase our systems, we need to host. So we will go for hosting. We even cannot build because we don't have electricity at campus. And if we will go for hosting solution, then we will have this split, geographical split. So certainly we will have to change our Zabbix configuration. So if one part of my cluster will be elsewhere, out Rehovot, which is our home city, I will need proxy.
Yes, definitely, yeah.
In addition, I read some roadmap of Zabbix 7 and I see some improvements in the front end, especially in graphical representation. So we certainly will try it. I don't know if we will switch, but there are some features that looks attractive because there are some features that I miss in Zabbix 6. For example, this thermal map graphs that were available in Ganglia. So you can see in one chart all your servers with different color. That servers that do nothing, they are, for example, blue, and servers that work hard, they are red. And also they have like dashboards when you have a small rectangle for every host showing its CPU load, for example, or TMP partition utilization. So it seems like Zabbix is going in a good direction with improving its graphical representation of the data, because monitoring has actually two purposes. First of all, it's monitoring. Okay, the manager of a system or sysadmin has to know that something happened. This is a good point, and it's done, I would say, perfectly with Zabbix. But another purpose of monitoring system is to supply the data for the management. So I want to have a picture, a nice picture of utilization of my cluster in order to come to my management and to say, hi, we overutilize our GPUs. I need some more funds to buy some more hardware.
Yeah, and 7.0 definitely.
And to come to management, you need nice graphics.
Yes, I agree. 7.0, a couple of alphas are already out. I've seen some of the new widgets. For example, the gauge widget, the improved pie chart widget, they're good. If you look at the roadmap, there's more to come. So certainly 7.0 will deliver some. And then as we move on, based on your feedback and feedback of other community members, we'll then decide where to go visualization-wise from then on. And many other new improvements in 7.0 when it comes to scalability and performance. We're here before Zabbix Summit. So during the summit, we'll see a couple of speeches focusing on internal design changes, and we'll see what kind of performance improvements await us. So if you plan to scale out even more, you'll definitely benefit from Zabbix 7.0 when it comes out. Which version are you currently on? I think I forgot to ask you that.
We run 6 LTS, 6.0019 if I'm not mistaken.
Do you plan on switching to 7.0 when it comes out? Or
at least we will check.
You will check, okay, yeah.
You know, monitoring is very important function, but it's not something that my user will feel if I change monitoring.
Of course, yeah.
So I can do it if I have free time, but if there are good changes in visualization, we certainly will try. Because it's important.
Yeah. That's probably a good way to go with things. Check it maybe in your own test environment, right? And then if you have the features that you need in production, deploy in production. Thank you a lot for the speech. I think we learned a lot about HPC, what you're monitoring, how you're monitoring it, and also some maybe vital requirements for HPC monitoring, like you said, scalability, automation. And yeah, we'll also see you at the summit with a speech. So we have that to look forward to, and we'll probably see you around. HPC monitoring is something that not everyone does, and if you have more use cases to throw our way, that would certainly be welcome. Thank you, Mark.